The Infisical Kubernetes Operator syncs secrets from Infisical to your Kubernetes clusters as native Kubernetes secrets automatically. Your secrets live in Infisical, but your workload runs in Kubernetes. The operator keeps Kubernetes secrets available at pod startup, it stays up to date after rotations, and it keeps them updated automatically. In this video, I'll walk you through what the Infisical Kubernetes Operator is, how it works, and how to deploy it in your cluster. The operator is built around 3 resources, and they reference each other in a chain. At the bottom, you have InfisicalConnection, which is just where the Infisical instance lives. InfisicalAuth points at that connection and then handles how the cluster proves who it is. And the secret resource points at the auth and says what to sync and where to put it. So the secret names the auth names the connection, and that's the whole chain. At runtime, the operator is going to run in your cluster. It uses the auth to log in over the connection, pulls the secrets that you asked for from Infisical, and then writes them out as a native Kubernetes secret that your pods read. And it rechecks on an interval so that it stays in sync. So if you've used external secrets operator before, this maps cleanly onto a secret store and then an external secret. You define the connection in auth once, and then every secret references them, instead of repeating that step for each one. And they don't just share the config. The auth logs in once, and then that token is reused across every secret that points at it. So adding more secrets doesn't multiply logins or memory usage. The piece that's a little different is the breadth. This one operator does 3 jobs. It syncs secrets in, which is what we're doing today. It can also push secrets from the cluster back into Infisical, and it can broker dynamic leased secrets as well. Push and dynamic will be their own videos. Today we'll stay on the sync in path. We install it with Helm, just a couple of commands into its own namespace. And the full docs with all of these chart values are going to be linked below. So that brings up the controller, and then it registers those custom resource definitions, the 3 that we just talked about. So we can kubectl get pods. The operator pod is running. And you can see the Infisical resource types that it registered. We're using 3 of them: InfisicalConnection, InfisicalAuth, and InfisicalStaticSecret. From here, the rest is just defining those 3, and then the operator takes it from there. We'll start with a connection. An InfisicalConnection just points your operator at an Infisical instance. We're on Infisical Cloud, so that's app.infisical.com. If we were in Europe, this would be eu.infisical.com. We'll apply this, and the operator confirms that it can reach Infisical. This ready column flips to true. You set this once, and then every secret in the cluster reuses it. Next, the auth. An InfisicalAuth references the connection, and then it picks up a method. We're on EKS, so we're going to use AWS IAM. Here's what's actually happening. The operator's pod already has an AWS identity through an IRSA role or an EKS pod identity that we attached ahead of time. It signs a request with that identity, sends it to Infisical, and Infisical verifies it directly with AWS. Apply it, and the operator authenticates and caches a short-lived token. Infisical supports a bunch of different ways for the operator to authenticate, and which one you reach for comes down mostly to where it's running, since it can lean on whatever workload identity that platform already gives it. On EKS, that's AWS IAM, and that has a real advantage because the whole handshake stays outbound. Like we just saw, Infisical checks the operator's identity with AWS, so it never has to reach back into your cluster, and your EKS API server can stay completely private. And last, the static secret, the part that does the work. The InfisicalStaticSecret references the auth. It then points at 1 or more sources from Infisical, each one a project, an environment, and a path. That pulls back every secret it finds at those locations. And then it writes them into a single Kubernetes object that it creates, and it keeps them in sync at this interval that you define. Now, this object is usually a native Kubernetes secret, but it can also be a config map for this non-sensitive config that you have in Infisical and you keep alongside your secrets. And the output doesn't have to be a one-to-one copy either. You could template it. So 4 separate values like host, port, user, and password become a single connection string, exactly the shape that your app expects. And there's conditional and loop support in there too for more involved cases. Apply it. If I kubectl get secrets, there's now a native Kubernetes secret in the cluster called my InfisicalSecrets. The operator created it, and it now owns the lifecycle. Infisical stays the source of truth here. What's in the cluster is a synced copy, and the manifest references it by path, never by value, so this is safe to commit to Git. A workload consumes it like any other secret. Here's a deployment pulling it with env from. Exec into the running pod, print a couple of these values, and we can see that they're live inside the container. Now, rotation. When a value changes in Infisical, 2 things have to happen. The secret has to update, and the workloads using it have to pick up the new value. If we change it in Infisical, within this refresh interval, the operator updates the Kubernetes secrets to match. And on Enterprise, you're not bound to this interval at all. Changes can be pushed instantly, so the secrets update the moment the values change in Infisical. But updating the secret isn't enough on its own. Pod that's already loaded the old value as an environment variable keeps running until something restarts it. That's where this annotation comes in, secrets.infisical.com/auto-reload true. With this set, when the managed secret changes, the operator rolls the workload for you. With external secrets operator, you typically add a separate tool, something like Stakeator, Reloader, in order to do this. Here it's built into the operator. So the difference is really with the ESO setup that a lot of teams run. So if you're already running ESO, where does this actually land? External Secrets Operator is a genuinely good, broadly compatible operator. And it even has an Infisical's provider, so some of you may already be pulling in Infisical's secrets to your clusters with the External Secrets Operator. The differences with the first-party Infisical's Kubernetes Operator are the reload being built in and the breadth. One operator that syncs in, pushes out, does dynamic secrets, as opposed to just having a sync and generators add-on. And on the Vault side, if you're weighing a move off it, Infisical has a migration tooling that translates concepts as opposed to just copying values. It maps your KV secrets over, turns the Kubernetes Auth method into machine identities, secrets engine rules into dynamic secrets, and your HCL policies into rules. I'll leave the link for that in the description as well. Now, a few things that are important once this is past one cluster. You can scope the install to specific namespaces with their own RBAC, so one team's secrets stay isolated. And every sync is governed and audited in Infisical. It exposes Prometheus metrics, and it runs on EKS, GKE, AKS, OpenShift, and the rest. And if you'd rather your secrets land as files mounted inside the pods as opposed to Kubernetes native secrets, I will leave our Kubernetes CSI driver and agent injector docs below. So that is the Infisical's Kubernetes Operator. 3 reusable resources get your Infisical's secrets into your Kubernetes cluster as Kubernetes native secrets. Your apps already know how to read them, reload is built in, and it's one operator across syncing secrets in, pushing them out, and brokering dynamic leases. From here, you can go deeper. Push and dynamic secrets each get their own video. And if you're coming from V1 of the operator or moving over from Vault, I'll leave migration docs for both in the description. Thanks for watching, and drop any questions in the comments. We'll reply to everyone. We'll talk to you in the next one.